Hello there. First of all, I'm going to apologize for all of the random noises you're going to hear in the background, like the dog walking past and probably my son laughing at what's on the TV. So first of all, let's review a little bit what you know about blood type already. Because you already know, hopefully you remember, that if someone has type A blood, that their blood cells, their red blood cells, have A surface proteins and they have anti-B antibodies. What that means is that if someone were to mix type B blood into a person who has type A blood, the anti-B antibodies would attack and destroy the B red blood cells that were put in there. So we don't want that to happen. But we're going to use that to our advantage today. If you have type B blood, you have B surface proteins and anti-A antibodies. So the anti-A antibodies will destroy any A red blood cells that come in contact with it. If you have type O blood, there are no surface proteins, but it doesn't matter whether it comes in contact with type A blood or type B blood. Those anti-A and anti-B antibodies are going to destroy those red blood cells. And then type AB blood has both A and B surface proteins, but it has no antibodies. So we're going to use this to our advantage because we are going to be testing for different blood types. If someone has type A blood and you add anti-A antibodies to it, the anti-A antibodies are going to react with the A red blood cells and cause the red blood cells to clump up. And you're going to be able to see that reaction as we mix the chemicals together. If someone has type B blood and you add anti-B antibodies to it, then the anti-B antibodies will destroy the type B blood cells and cause them to clump up. If you have type O blood, because there are no surface proteins, it doesn't matter if you add anti-A antibodies or anti-B antibodies. Neither one of them is going to cause the blood to clump up. And if someone has type AB blood, because they have both A surface proteins, anti-A antibodies will attack that. And they have, someone with type AB blood has type B surface proteins, anti-B antibodies are going to cause that to clump. So let me show you what I mean, because I know that was probably pretty confusing. Now here we have what is called a set of wells, and this is basically the wells are 3 indentations in a piece of plastic. The one that's in the light right now is labeled type A. The one that's in the light right now is labeled type B, and the one that's over here on the side is labeled type RH. And the same thing happens with RH. And let me just show you. I think it's going to be easier if I demonstrate. So I'm going to put 2 drops of simulated blood. This is not real blood. Simulated blood in each of those, and I have these serums. There are 3 different types of serums here. The yellow one is anti-B. Don't know if you can read that. The blue one is anti-A. And the green one is anti-RH. So I'm going to add 2 drops of the anti-A serum to the A well, and then I'm going to add 2 drops of the anti-B serum to the B well, and then I'm going to add 2 drops of the anti-RH to the RH well. Well, I got 3. That's all right. So I'm going to take a toothpick and I'm going to stir these up. And if clumping occurs, then we have a particular type of reaction going on. Okay, there's that one. I'll show you more up close here in just a second. Sometimes it takes a while for this to happen. You would have been doing this in class had you had the opportunity. But seeing as how you didn't have the opportunity through no fault of your own. Now I'm using a different part of a toothpick every single time because I don't want to contaminate the different wells. Okay, now from where you're looking right now, my guess is that you can't really see what's going on here. So let me show you. Had we been in class, what I would have told you is put these on a piece of paper and then see if you can see through them. Now, let me get this up here a little bit more. If you can see the print underneath. Now for these two, like I said, sometimes it takes a while. It's not really that you can't see through all the way, but when you look at this, hopefully what you can see is that the A and the RH are cloudy and the B is still perfectly clear. Here, let me bring it up a little bit closer to you. I won't be able to tell until afterwards whether you can actually see this or not. But the A is cloudy, the RH is cloudy, and the B is clear. That means that this blood sample is A positive because there was clumping taking place in both the A and the B. But not, or excuse me, the A and the RH, but not the B. All right, let me do another one for you. Hold on 2 seconds so I can clean out the wells. We don't want contamination between the wells. All right, so I'm going to use a different blood sample this time. I'm going to put 2 drops of blood in each of the wells. And yes, I am making a mess. This working from video is very challenging. So now I add the anti-A serum to the A well. I add the anti-B serum to the B well. And I add the anti-RH serum to the RH well. And once again, it gets 3 drops. So now when I stir, I feel like I should be humming the Jeopardy theme song right here. Do 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 do. Oop, missed that note. Boom, boom. All right. So now, when you look at this one, all of them appear to be clear. There's no cloudiness in any of them. So that means there's no A surface proteins, there's no B surface proteins, and there's no RH surface proteins. That means this blood sample is an O negative. Now, I know that this is a very quick introduction, less than 10 minutes, and I know that you're probably going, wait, what? I don't really get this. It's okay. I'm going to be sending you tomorrow a worksheet for you to identify the different types of blood types based on pictures of doing this, and that hopefully will help. Thanks a lot.